Okay, let's continue. So this is the last section, RF system analysis. Now putting on through some basic understanding what is an RF, video, key terminologies. We have looked at architectures, we have looked at different blocks, we have looked at PA, LNA, filters, we have looked at sensitivity, noise figure, gain, attenuation, right? We'll put together all of those things and we'll do some very basic calculation. Okay, we'll do a basic calculation for the transmitter and for the receiver. Okay, so transmitter power analysis. So we'll put together all the gains and losses on the transmitter side and we'll calculate the transmit power. This is what we'll do on the transmitter side. What will we do on the RX power? We will put together all gains and losses on the receiver and we will calculate the sensitivity. Then, okay, then once we know the sensitivity, we can also look at the minimum power. Okay, that is actually generated by the system. Okay, we have defined sensitivity. It's the minimum RX power that is needed by the baseband for given SNR to intelligently demodulate and decode a signal. So we have already seen this definition. So let's look at the TX power calculation. So consider this system. So this is a simplified block diagram. So I have a transmitter here. The power level is 0 dBm. The power level is 0 dBm. Then I have a low pass filter and I told you somebody asked a question, can I use a gain or loss? So here I have said it's a gain, insertion gain. So I'm using minus 1.5 dB. If I had called it insertion loss, I should have said plus 1.5 dB. Okay, here I'm using the gain terminology so that it is consistent for all the blocks. So every block I'm calling it as gain. So here I'm calling it as minus 1.5 dB. This is not adding any gain. Okay, this is removing this is actually crossing attenuation. Then we have a power amplifier which has a gain of 25 dB. Then there is a band pass filter, another filter. Again, this is not providing gain, but I am writing it as gain, so it is minus 2 dB. So what is the calculation that I have to do? I have to calculate what is the power at input to this antenna. Okay, if I calculate that power, I know that I have to see if that power meets the requirement so that it can be transmitted over the air. Okay, this is the calculation. Okay, this is the goal. What is the power at input to the antenna? So what do we do? Since it's all in dBs, the calculation becomes simple. What do we do? So you take the input power. Okay, I have 0 dBm power coming into the system. Then I add different gains. So I have PTX. This is the transmit power, which is given by the low power section. Then these are all the different RF blocks that I have. So I have the first low pass filter gain, then the PA gain, then the band pass filter gain. So I add all these numbers. So see, so I have taken 0 dBm, then I have added a loss of minus 1.5 from the low pass filter. Then the power amplifier is giving a gain of 25 dB. Then there is another band pass filter which is giving a loss of minus 2 dB. So what is the total power at the output? 21.5 dBm. So the question is, once you get this, let's say as a designer, you have designed this system. Now, if it's a 3G, 4G or a 5G system, you have 3GPP specification. So you have to look at the 3GPP specification and see that whether this meets the requirement. If it does not meet the requirement, then you have to go back and redesign the system. Okay, this is transmit side. Let's look at the RX receive side power calculation. So I have, this is a receiver. Okay, here remember on the slide, so transmitter, so the signal, so the the power TX power was going like this, and it was going through the antenna to the air. interface. Now if it's receiver, remember it is coming from the air side and it is entering the antenna and it will go through rest of the blocks. Okay, so the calculation also we do from right to left here. Okay, right to left calculation. Okay, we go like this, right to left in receiver. So this is a receiver system that is that is given to you. So again we have antenna and I have given what is the input power coming to the antenna. So if you look at the previous slide, you can see the right. See the difference here. Transmit power was 21.5 dBm. Compare this with the receiver power. See, it is very small. It is minus 100 dBm. Let's say this is the power that is entering the antenna. Then there is a bandpass filter. Let's say this is the loss that is giving. Then there is an LNA, which is 20 dB gain. Then there is another low pass filter, which is giving minus 1.5 dB. Now I have taken the noise figure. So someone asked a question, can I reduce the, how can I improve the noise factor or noise figure? So clearly, see, I have taken a system noise figure. This is a system level noise figure, okay, comprising of these three blocks. Now, if I reduce the noise figure of individual blocks, let's say LPF or LNA, typically LNA noise figure is critical. So if I do a good design and reduce the noise figure here, this noise figure will also reduce. Okay, so ideally I want 0 dB noise figure. Okay, this is impractical, but this is the best case number. So 3.5 dB, is it good or bad? It depends. Okay, it depends on what is the final sensitivity value that I want, that I'm expecting. Okay, so look at this band pass filters and low pass filter. So we had seen this in the transmitter also. So the purpose is same. We have discussed about the filters before. You want to remove unwanted frequencies, you want to remove, and you want to allow only desired frequencies. Right? You want to allow only desired frequencies. Why do we say desired frequency? Because that is our band of interest. We want to allow only that. Okay, now what is the goal? So let's say I have the power coming from here. It will pass through this system. Then let's say at this point, let's say this is the baseband input or this is the transmitter input. I'll do a measurement. I'll check the received power and I will say, see if it's more than the sensitivity. So if you remember, we discussed about sensitivity. This is the minimum expected signal. Okay, minimum expected signal. Without this minimum expected signal, if the signal is not at least sensitivity, then your receiver cannot, recover the information. It cannot recover information. So you need at least this minimum sensitivity level. Let's see if this design meets that requirement. Okay, so that's the goal of this block, this calculation. So calculate received power same as we did for the transmit side. What we did on the transmit side, we do the same here. What do? We know what is the power that came. So here we are doing from right to left. So see, first is minus 100. So right to left we are doing. So we have minus 100 dBm coming in. Then there is a first bandpass filter. It gives minus 2 dB. That is this block. Then we have a 20 dB gain LNA. Then I have loss of minus 1.5. I add it here. So finally I get a number minus 83.5 dBm. Okay. Now is this sufficient for the receiver to work? Don't know. We don't know yet because I don't know what is the sensitivity level. Okay. So let me do a theoretical sensitivity calculation also here. Okay, I'll show you a theoretical sensitivity calculation. So what is the equation? We looked at this equation, KT BF. Out of that, I told you KT we already know. It's a standard number, minus 174 dBm per hertz. We don't have to change that number. Take that number. Okay. I've taken minus 174 dBm as the number. What is the next number? So next is bandwidth. So in this example, I'm taking our required band. I told you all these filters, we have these different filters, right? So I'm defining a bandwidth of 20 megahertz. Okay, let's say this is a 4G system or a 5G system. I have 20 megahertz bandwidth. So since it's in megahertz and everything calculation is in dB, you have to take a dB scale. So I'm doing 10 log 10 of 20 megahertz. Okay. Next number is noise figure. So we already know that number. It is 3.5 dB. So I've taken that 3.5 dB. Then there is a SNR requirement. So for sensitivity, I told you in the previous slide. So there is a SNR expected, right? So this is a expected SNR. So this is required. So let's say the designer has said that he wants at least 10 dB SNR. Now, if you put together all these numbers, right, do the calculation, you will get it as minus 87.5 dBm. Okay. Now, we erase the question, the goal. What is the goal? What is PRX? I have got minus 83.5 dBm. What is sensitivity? Minus 87.5 dBm. Question is this greater than this? Okay. You think. I'll tell you the answer, but you think. Okay, so the answer is yes. Remember, these are negative scales. So minus 83.5 is more than 87.5. So, but if it was a positive number, obviously 83.5 is smaller. But since it's a negative in the negative scale, right? So 83.5 minus 83.5 is greater than minus 87.5. So this system meets the sensitivity goal. So that means the receiver can now recover the signal. Okay. But if you're doing a practical 3G, 4G or 5G system, this sensitivity number is given by 3GPP. So you have to design a system such that you meet the condition given by 3GPP. Please click on like and subscribe to our channel and click on the bell icon for regular updates.